Now let us look at fifth subdivision. This is also a prove that type of question. So the left hand side is cos A minus sin A plus 1 divided by cos A plus sin A minus 1. So the numerator terms and the terms in the denominator cannot be cancelled because they have plus and minus sign associated with other terms. So we are going to take the left hand side, and so basically when we look at the right hand side, it's very clear that we need cosec A and cot A. That is what is expected out of the question. So now cosec A is nothing but 1 by sin A. We know that it is nothing but 1 by sin A, and cot A is nothing but cos A by sin A. I repeat, when you look at the right hand side, cot A is nothing but cos A by sin A, and cosec A is nothing but 1 by sin A. Something that is common in both of these is dividing it by sin A. So therefore, we have to divide the left hand side throughout by sin A in the numerator as well as the denominator. There is no meaning in dividing it only in the numerator, and it is not mathematically possible also. So what we do is we write a step which is dividing the numerator and the denominator by sin. So before proceeding on to this step, why do we do this? Because in the right hand side, it's very clear that we need cosec A. Cosec A is nothing but 1 by sin A. That is one of the reasons we divide it by sin A. And also cot A is nothing but cos A by sin A. Out of this cos A by sin A, cos is already given in the question, if you can see here. So when we divide it by sin A, it will become cot A, which is required in the right hand side. So this is something that we need to know. So when we divide the numerator and denominator by sin A, what happens? Let us see. So the numerator term is cos A, and then we have divided by sin A. And then the next term is sin A, and then we divide it by sin A. And then the next term is 1, and we divide it by sin A. Likewise, even in the denominator, we have cos A by sin A. And then we have sin A by sin A. And then we also have minus 1 by sin A. So like this, we are dividing all the terms in the numerator and all the terms in the denominator by sin. Now what we get out of this is the first term cos A by sin A becomes cot A. And the second term is sin A by sin A, it becomes 1. And the third term 1 by sin A becomes cosec A. This was our idea, divided by. Likewise, the denominator we get cos A by sin A, which is cot A, plus sin A by sin A, which is 1, and 1 by sin A is cosec A. So this is something that we need to know. And then we kind of reorder this. So this can be reordered by writing it like this. So we write the cot A term first, and then cosec A term second, and then the minus 1 at the end. Likewise, in the denominator also, we write the cot A term first, and then the cosec A term, and then the plus 1 term at the end. This is not a necessary step, but this we do to take the minus 1 and 1 in the rightmost part of the expression, just for symmetry. You will understand it eventually. So what do we do after this is, so we have almost got the answer. If you look at the question, the right hand side, we have almost got the answer, but except some extra terms like this. So how do we approach this? This 1 has to be eliminated somehow in the numerator. Of course, the whole of denominator should also be not there. So what we do is, we know this identity called 1 plus cot square A equals cosec square A. We know this identity. And from this identity, 1 can be equated as cosec square A minus cot square A. So this can be done. I repeat, this is the identity that we all know. This is the third identity, 1 plus cot square A equals cosec square A, from which 1 will be equal to cosec square A minus cot square A. Now, when we substitute this cosec square A minus cot square A, in the place of this 1, when we substitute it in the place of this 1, only in the numerator, not in the denominator, then what happens? Let us see. Now the expression becomes cot A plus cosec A minus 1. In the place of 1, I am substituting cosec square A minus cot square A. So like this I'm doing. And denominator I'm not going to change at all. The denominator is going to remain cot A plus cosec A minus 1. You will understand why I'm not changing it. The numerator alone, if you look at it carefully, in the place of this 1, I am substituting this expression, cosec square A minus cot square A. In the place of this, the minus remains here. If you look at it carefully, you can see this minus is very well here. Sorry, not here. This minus is here. And in the place of 1, we are substituting cosec square A minus cot square A from the identity. Now, in the next step, what happens is, in the numerator, the other two terms are as such, that is cot A plus cosec A. But this cosec square A minus cot square A can be written as cosec A plus cot A into cosec A minus cot A, wherein I am applying A square minus B square formula. So it becomes like this, whole divided by cot A plus cosec A minus 1. Sorry, cot A plus, sorry, this is minus, I'm sorry. So cot A minus cosec A plus 1. So this term should be negative. Yeah. So again, I'm repeating what I'm doing over here is, in the place of this 1, I'm substituting cosec square A minus cot square A. I have not changed anything else. All the other terms remain the same. And when I say this looks like A square minus B square, it will be A plus B into A minus B, as you all can see. That is cosec A plus cot A into cosec A minus cot A. So the next step, what we are going to do is, we are going to take this cot A plus cosec A common out, because it is there in both the terms. So if you look at it carefully, this is one term and this full thing is another term. So out, and which is separated by a negative sign. So out of these two terms, we can take cosec A plus cot A as common out, and that will be the next step that I'll be doing. So we have come to the end of this question answer, wherein what we have here is this cot A plus cosec A is present in this term as well as this term. So basically, when you look at it, this looks like we have two terms, 1 and 2. So this is one term and this is a second term. In both the terms, we can see cot A plus cosec A is present. And when we take this cot A plus cosec A outside as common, we get cot A plus cosec A. This has been taken outside. And wherever cot A plus cosec A is there, you will get a 1. We will get something like this. And there is no change to the denominator, as I always keep saying. The denominator remains like this, cot A minus cosec A plus 1. Please observe what I'm trying to tell you. In the numerator, this term and this term have been taken out as common. So in the place of them, you'll be getting 1. So basically here you will be having 1, minus here also you'll be having 1. Because both of them have been taken out. And I have mentioned this one here, if you can see, but the other one I have not mentioned. Instead, I have just written minus bracket cosec A minus cot A. Now, when we take this minus inside the bracket, what do we get? So in the outside, you have cot A plus cosec A in the numerator. And when you take this minus inside, you get 1 minus cosec A. Minus into minus becomes plus cot A, whole divided by, you get cot A minus cosec A plus 1. I repeat, in the numerator, minus into cosec A becomes minus cosec A, and also minus into minus cot A becomes plus cot A. That is what I have written. Now, if you carefully observe, you can very clearly see that the denominator is cot A minus cosec A plus 1. The numerator is also cot A minus cosec A plus 1. So both of them will get cancelled, leaving you with cot A plus cosec A, which is our required right hand side. This is our right hand side, and this is what we are supposed to find. If you look at the right hand side in the question, it's very clear. So let me repeat the last few steps. So basically, I have numbered two expressions as 1 and 2 in the bottom of the screen. And I have taken cot A plus cosec A outside. So in the place of cot A plus cosec A, I'll get 1 here. So you'll get 1 minus cosec A minus cot A and then divided by whatever. So now in this term, when we take this minus inside, you will be getting it like this. And you can very clearly see denominator we have plus cot A, numerator also we have plus cot A. Denominator we have minus cosec A, numerator also minus cosec A. Denominator is plus 1, numerator is also plus 1. And it's in multiplication, so we are able to cancel, leaving you with cot A plus cosec A, which is the answer. Now let us look at sixth subdivision. So this is the question. We need to prove that whole root of 1 plus sin A by 1 minus sin A equals ck plus tan A. So as in every problem, we are trying to take the left hand side. Okay. And in the left hand side, what they have given is whole root of 1 plus sin A into 1 minus sin A. If you look at the right hand side, what we need to prove, it is very obvious that the right hand side does not have a square root, but the left hand side has a square root. And one of the ways in which we can eliminate a square root is by squaring. Because when you have a square root and when you have a square term inside, this square and this root can be cancelled. This is something that we know. So, but there is no square term also. So I repeat, in the right hand side, the root is not needed, but in the left hand side, we have a root. So the first step is to eliminate the root. But in order to eliminate the root, suppose if we have something like this, if we have a square term like this square and this root can be cancelled, which will pave a way for us to get the answer, I mean the right hand side. So how do we eliminate this root, or how do we get a square term? By taking the conjugate. So we all know the step called conjugate, wherein we take the opposite sign and then we multiply it in the numerator and denominator. So we are taking conjugate. We choose the denominator, this term, and we take the opposite sign here. If it is 1 minus sin A, we take 1 plus sin A. This step is called conjugate. And the same thing we repeat in the numerator also. This is something that we do in irrational concept also. So this is what we are doing. We are taking conjugate, which means in the denominator, whatever term you have here, the opposite sign we take it here and we repeat it in the numerator. So after taking conjugate, what happens? So in the numerator, we get 1 plus sin A the whole square. So this is what we were expecting. Somehow we wanted to get a square so that the square and the root will get eliminated. So this square is hard earned, in the sense we have got it after an important step. So please don't square it, like don't apply A plus B the whole square and expand it. The whole point of getting a square is to eliminate with the root. So please don't expand it. In the denominator, we have A plus B into A minus B. If you carefully observe, we can see A minus B into A plus B, which will be A square minus B square. We get something like this. So in the next step, this will become root of 1 plus sin A the whole square. I am not expanding the numerator for whatever reason I told you previously. In the denominator, this A plus B into A minus B has become A square minus B square, which is 1 square can also be written as 1. 1 minus sine square A is cos square A. We all know this. 1 minus sine square A is cos square A, according to the identity number 1. Now you can see that both have square terms, which can be taken as whole square. So what I mean by that is we have 1 plus sine A by cos A, and these squares can be written as whole square, and we have a whole root outside. I repeat, this square and this square, both the squares have been put as a common square, like this. So 1 plus sin A by cos A the whole square, and this root and this square can get cancelled. The whole root and whole square will get cancelled, and you are left with 1 plus sin A by cos A. Now when you separate the denominator, that is 1 by sin A plus sin A, sorry, 1 by cos A plus sin A by cos A. I am separating the denominator, 1 by cos A plus sin A by cos A. 1 by cos A is sec A, and sin A by cos A is tan A, which is the required right hand side. So this is how we do the sixth subdivision. So this is seventh subdivision, and there is an LHS and there is an RHS. The right hand side is clearly given as tan theta, which is basically sin theta by cos theta. So somehow if you are able to make this as sin theta by cos theta, then we are done. So how are we going to proceed? In the left hand side, we take the left hand side, LHS, and we try to take the sin theta term as common out in the numerator. So when you take sine theta as common out, in the place of sine theta, you get 1. And in the place of the next sine theta term, you get sine square theta. I repeat, in the numerator term, when I take sine theta as common, because it's present in both these terms, now in the place, when we take it as common, in the place of sine theta, you will have 1. And here there are 3 sine theta, sine cube theta. So that will boil down and reduce as sine square theta. You can see here. Likewise, in the denominator, if I take cos theta as common out, I'll be getting 2 cos square theta minus 1. In the denominator, if I take cos theta as common out of this cube, 1 has been taken out, so you will be left with square. And also this cos theta is going out, so in the place of that cos theta, you will have 1. Now we have almost got the right hand side in the first step itself. You can clearly see sine theta by cos theta, which is tan theta. But the other terms are kind of a hindrance here. So we have to cancel out the other terms. So how are we going to do this? So this can be done by actually using the identity sine square theta plus cos square theta equal to 1. So that is what we are going to do now. So this sine theta by cos theta will become tan theta. So I'm making it as tan theta, which means we've already gotten the right hand side, except for other terms. So how I am cancelling them off, we will learn. So now in the numerator, you can see you have a 1. In the place of that 1, I am substituting sine square theta plus cos square theta, which is the identity. In the place of this 1, I am substituting sine square theta plus cos square theta. And what is left? Minus 2 cos square theta is left in the numerator. I repeat, sine theta by cos theta has been transformed to tan theta. We all know that is the formula. In the place of this 1, I am substituting sine square theta plus cos square theta according to identity. And even in the denominator starts like 2 cos square theta minus. Even in the place of this 1 also, we are going to substitute sine square theta plus cos square theta, but this time with a bracket because there is a negative term outside. So you will be having it like this. So basically what I'm doing here is in the place of this 1 and in the place of this 1, I'm substituting the identity sine square theta. So 1 minute. Plus cos square theta. In both the ones, we are substituting sine square theta plus cos square theta. I hope it's clear. And now what we do is, in the next step, if you further simplify this, you get tan theta into, in the numerator, we get sine square theta minus cos square theta. That's what we get in the numerator. How? Because this is cos square theta, this is minus 2 cos square theta. So this is nothing but x minus 2x, where x is cos square theta. So x minus 2x is minus x. Likewise here also, cos square theta minus 2 cos square theta is minus 1 cos square theta. That is what I have written over here. Likewise, in the denominator also, we have, so when you look at the denominator, we have something like this. So if you observe the denominator, you get 2 cos square theta minus, so when this minus goes in, this becomes minus. So we are getting cos square theta in the denominator minus we get sine square theta. So this is something that we need to know. Just a minute, there is a small error in the question. There is a small error in the answer. So this should be basically sine square theta, not cos square theta. I'm sorry, I've copied this wrongly. Here, this should be sine square theta. Yeah. So now the same procedure. So you have tan theta into, so you have cos square theta. I'm writing cos square theta first. And the other two terms you can clearly see sine square theta minus 2 sine square theta is minus sine square theta. Likewise, in the denominator also, 2 cos square theta minus cos square theta, minus goes in, becomes minus. So you get cos square theta, and whatever you're left with is sine square theta, minus sine square theta. So you get the same term in the numerator and denominator, which helps us to cancel them off, leaving you with only tan theta, which is our required right hand side. So this is how we do the 7th subdivision. Now let us learn how to do 8th subdivision. In the left hand side, we have given two big terms, sin a plus cosec a the whole square and plus cos a plus sec a the whole square. In the right hand side, we need some terms. Now it's very clear from the right hand side that we need square terms. So we have to square the left hand side. So if I square the left hand side, I'll be getting sin square a plus 2 sin a cosec a. There will be a middle term, 2ab term. That's very, very important. Plus cosec square a. I have just expanded this one term. I have not even taken the second term. So this looks like a plus b whole square, which will be a square plus 2 into a into b plus b square. Likewise, I'm going to expand the other term, which is cos square a square term, and then 2ab term, which is 2 cos a into sec plus sec square a. So now I have expanded this term. The second term I have expanded, which is nothing but a square plus 2ab plus b square again. Now, it's very clear that sin square a plus cos square a will become 1 according to identity. So this will become 1. And cosec square a, we have an identity called 1 plus cot square a. And for sec square a also, we know an identity which is 1 plus tan square a. Just a minute. So I repeat, sin square a plus cos square a has become 1. Cosec square a is nothing but 1 plus cot square a. And sec square a is nothing but 1 plus tan square. And the other terms that we are left with is 2 sin a cosec a and 2 cos a sec a. Let me re-explain this step. So basically what I have done is I have taken the left hand side and I have just squared it. So when you do a plus b whole square to this step, you get this. A square plus 2 into a into b. A is sin a, b is cosec a plus b square. Likewise, when we apply a plus b whole square to this expression, we get this. And in the next step, sin square a and cos square a will get added and they will give you this 1. And please look at the blue color. Cosec square a has been written as 1 plus cot square a according to identity. Now, some of you might be wondering, now, okay, sin square a plus cos square a, I have made it as 1. But why have you converted cosec square a into the identity called 1 plus cot square a? Because in the right hand side, we need cot square a. So that's why I keep on saying that you have to keep on seeing the right hand side. Okay, so 1 plus cot square a. Likewise, try to look at the green color. This sec square a has been written as 1 plus tan square a, again another identity. And the rest of the terms I have just written it here. This 2 sin a cosec a and 2 cos a sec a, I have written it over here. So this is how I have split this. Now, what happens if you clearly observe, you can see that this 1 and this 1 will become 2. So you get 2 plus cot square a plus, sorry, it's not 2, it's 3 because there are 3 ones. So this one, and this one will get added and you will get 3. So you'll be getting 3 plus what we are left with, cot square a plus tan square a plus other 2 terms. What we can do is we can write this like this. We could have written it in the previous step, but I just want to give you some clarity. We can write it like this. So in this step, we can write this cosec a as 1 by sin a so that they get cancelled. Likewise, in the last step also, 2 cos a into this sec a can be written as 1 by cos a. Now it's very clear that this cos a and this cos a will get cancelled. This sin a and this sin a will get cancelled, leaving you with 7 plus tan square a plus cot square a, which is what is expected in the right hand side. It's even more simpler to do this step here itself, but I just did one more step to make you understand it better. So it's very clear because you have a 2 here, you have one more 2 here, which will add and become 4, and you already have a 3 here. So all these 3 will get added and become 7, leaving you with these two expressions, which is 7 plus tan square A plus cot square A. Now let us learn how to do the 9 subdivision. So 9 subdivision looks quite complex in the left-hand side as well as in the right-hand side. So the strategy that we're going to follow is we're going to take the left-hand side, simplify it, bring an answer. Right-hand side also simplify it and bring the same answer. So now in the left-hand side, we can see there is cosec minus sin A into sec minus cos A. So during problems wherein we are not sure of what to do, we know very well that we have to simplify it in terms of simple trigonometric ratios, which is we are going to convert all of them in sine and cos. So we know that cosec A is nothing but 1 by sin A. And the other sin A we are not going to change because it's already in sine. Our idea is to simplify it into sine and cos. Likewise, this ck can be written as 1 by cos A, and the other cos A I'm going to have it as such. And in the next step, I'm going to take LCM. So when I take LCM, I'm getting 1 minus sine square A by sin A. So what I'm doing here is somewhat like this. Here it is divided by 1. And when I multiply it by sin A in the numerator, it becomes, already there is a sin A, it becomes sine square A. And that is how you take the LCM. So this is what we get for the first step here. Likewise, when we take LCM for the second term, we get 1 minus cos square A divided by cos A. This is the LCM for the second term. And we all know that 1 minus sine square is nothing but cos square A according to identity divided by sin A. And we know that 1 minus, so see, this is the identity, right? Sine square A plus cos square A is equal to 1. So from this identity, so this is the identity. From this 1 minus sine square A will be cos square A and 1 minus cos square A will be sine square A. That is what I'm going to do now. So into 1 minus cos square A will become sine square divided by cos A. Now it's very clear that one of this cos A and one cos A in this will get cancelled, and sin A and one of the sin A in this will get cancelled, leaving us with an answer which is cos A sin A or sin A cos A. So this is what we are getting. This is the most simplified thing, sin A cos A. We can't do any further, so we are just stopping it there. And now we go to the right hand side. In the right hand side also, we are applying the same strategy. What I'm doing here is I'm going to convert everything in terms of sin A and cos A. Only exception is that everything is the denominator. Now tan A can be written as sin A divided by cos A. Okay. And cot A can be written as cos A divided by sin. This is very important. And now I'm going to take LCM in the denominator. So when I take LCM in the denominator, I'm getting sin square A plus cos square A divided by sin A cos A. This is what I'm getting. In the denominator, I'm taking LCM. The numerator remains 1. So the LCM will be into sin A into cos A. It's like cross multiplication. There is already a sin A, so this will become sin square A plus cos square A by sin A cos A. Sin A cos A is the common denominator after taking LCM. We all know that sin square A plus cos square A is 1. So this will become 1 by sin A cos A. So this has become 1 according to identity. And we know that this, when it comes to the numerator, becomes reversed and you get sin A cos A. Denominator of denominator is numerator. So this, when it goes up, it becomes sin A cos A by 1. So you're getting sin A cos A. So the left hand side is also sin A cos A, and the right hand side also we have brought it as sin A cos A. Therefore, we can conclude by saying the left hand side is equal to right hand side. So this is how we approach this problem. Quite an easy problem. I hope it's clear. When it comes to 10th subdivision, we have two parts, 1 plus tan square A by 1 plus cot square. That is the left hand side. And 1 minus tan A by 1 minus cot A the whole square. That is the right hand side. And both of this, we should get it as tan square. That is also given in the question clearly. Now, according to the identities, we know that I have taken the left hand side here. we know that 1 plus tan square is nothing but sec square A. And similarly, according to the third identity, we know that 1 plus cot square A is cosec square A. And sec square A can be written as 1 by cos square A, because the inverse of sec is cos. And cosec square A can be written as 1 by sine square A, because the inverse of cosec is sine. Now, in the next step, this goes to the numerator and gets reversed. So basically, we'll be getting 1 divided by cos square A into sine square A by 1. This is what we'll be getting. Now, this is nothing but sine square A by cos square A, which is tan square A. So we have already got this in the left-hand side. I repeat, I have made these equal according to the identities, and sec square A is 1 by cos square A, that is the inverse. Cosec is 1 by sine square A, and when this goes up, it gets multiplied and we get sine square A by cos square A. This is nothing but into 1 is nothing, it has no value. So sine square A by cos square A, this will be nothing but tan square A. We know that sine by cos is tan, likewise. In the right hand side, it is given as whole square, and this cannot just like that be taken inside. So how we are going to deal with this? So now, before squaring this, we can actually do something like this. 1 by tan A, 1 minus tan A, 1 minus, this can be written as 1 by tan A in the denominator. And then you have a whole square outside. Let me bring the whole square at the end. Now, only one thing I have done is this cot A has been transformed as 1 by tan A, because the inverse of cot is tan. And in the next step, what I'm doing is I'm going to take the LCM. I'm still not taking the whole square. The numerator remains 1 minus tan A, and the denominator is tan A minus 1 by tan A. This is the denominator. This is the denominator, and this is the whole square. This is something that we need to do. I repeat, I have just taken LCM in the denominator. This is divided by 1. So you get into tan A into tan A. That's how I'm getting tan A minus 1 by tan A. That is the LCM part. Now, in the next step, what I'm doing is, in the numerator, I have 1 minus tan A. In the denominator also, if you have 1 minus tan A, it will be easy. So what I'm trying to say is, this goes to the numerator within the square. So now this becomes into tan A divided by tan A minus 1. Whole square. I repeat, within the bracket, this term that is in the denominator, this term has been taken and it has been reversed. When it goes to the numerator, it gets reversed, which means this will come to the numerator and this will go to the denominator. And that is what I have done. And still I have not squared it. The square is still there in the outside. Now you can cancel these two if they were of the same order, but they're of different order. Now what I do is I introduce a minus sign and I change the order. We all know that if we introduce a minus sign, the order will get changed. I have changed the order. If it is a positive term, then there is no problem. Since it's negative, I'm introducing a minus sign, I'm changing the order. So that minus into tan A will become minus tan A, and minus into minus 1 will become plus 1. That will be maintained. So into, you get tan A divided by tan A minus 1. Now what happens is, this tan A minus 1 and this tan A minus 1 will get cancelled. In order to cancel them only, I reverse the terms in the numerator. Now what you get is minus tan A the whole square is what we get at the end after all the cancellation. Minus gets squared and you get plus, and tan A the whole square is tan square A, which is also the left hand side. So this is what is expected out of question number 10.